Welcome learners to Form 2 Mathematics. My name is Teacher Jane Hope. Today I would like us to look at indices. Indices is a Form 2 topic. But I want us to look at this question which was tested in KCSE in year 2021. So let us look at it. Find the value of x, learner. Find the value of x in this equation. Find the value of x in this equation. So learner, the first thing that you come and do here is to express this 8 to base 2. So 8 is the same as what, learner? It is the same as 2 raised to what? Raised to 3. 8 is the same as 2 raised to 3. Then you now raise this to x plus 1. You raise it to x plus 1 like that, learner. Then you say minus 2 raised to 3x minus 1 is equals to 120. You cannot be able to express 120 using base 2. So let us use it the way it is. Then from there, learner, after expressing these two terms using a common base, and that is 2, multiply the powers here, learner. When you have a power raised to another power, according to the laws of indices, you multiply these powers here. And therefore, this becomes 2 raised to what? 3 times x is 3x plus 3 times 1 gives you 3. Good. Then you say minus 2 raised to 3x minus 1 is equals to 120. So learner, if you look at our problem now, you can see that 2 here is raised to 3x plus 3 and 2 here is raised to 3x minus 3. Separate these. Separate it through here according to laws of indices. So I can write this as 2 raised to 3x times 2 raised to 3. Look at that, learner. According to laws of indices, when you are multiplying common bases, learner, it is the same as just writing the common base, which is 2. Then you add the powers. I hope you have got that. Then you add the powers. If you add these powers, you'll get this. So this, learner, in other words, this is the same as this. We continue and say this is minus, we fix a minus there, 2 raised to what? Again, you separate this through there. I can write this as 2 raised to 3x times 2 raised to negative 1. I can separate it like that. Because again, if you are multiplying common bases, you can just write the common base here, and then you add the powers if you are multiplying the bases. And therefore this, learner, is equals to 120. Good. Looking at this, learner, now, you can see this term here and this other one here, they are the same. And therefore we say, let 2 raised to 3x be y. 2 raised to 3x be y. So replacing it here, learner, we write y times 2 cubed minus y times 2 raised to negative 1 is equals to 120. So learner, this is what? 2 cubed is what? It is 8. So 8 times y gives you 8y minus y times what, learner? 2 raised to negative 1. According to indices, this is the same as the fraction 1 over 2 raised to a positive power here, which may be 1. We can leave it like that. So it is 1 over 2 raised to power 1, which is the same as a half. And therefore this, learner, gives you 120. So we talk of 8y minus, multiply this, gives you y over 2 is equals to 120. From here, learner, you can remove this denominator by multiplying everywhere with it. Multiply by 2, multiply by 2. 2 and 2 will cancel out there. Look at this, learner. 2 times 8y gives you 16y minus what? 2 and 2 have cancelled out, and therefore you are left with y. Multiply 120 by 2 gives you 240. And therefore, Lana, 16y minus y gives you 15y, 15y is equals to 240. Divide by 15, divide by 15. And therefore, your y, Lana, is what? Your y gives you 16. Gives you 16. But y was what, Lana? Our y was 2 raised to 3. Look at this. Our y was 2 raised to 3. So y is 2 raised to 3, which is equals to 16. Which is equals to 16. Look at that. Y was 2 raised to 3, which is equals to 16. And so express these two using common base 2. So 2 raised to 3x, Lana, is equals to 2 raised to what? To 4. Lana, the bases are the same. Once the bases are the same, equate the powers. Equate the powers like that, Lana. Divide by 3, divide by 3. And therefore, your x is 4 over 3, which I can write as x is equals to 1 whole 1 over 3. And that is indices. So Lana, go and practice on this problem. Go through it slowly, practice until you get this answer here. All the best, Lana, in indices. God bless you.